Okay, so hi everyone. So today in this video, I will be discussing solutions to the problems of Codeforces Round 876 Division 2. Basically, we will be discussing the first three problems. So let us go to each problem one by one. Okay, so this was the first problem, that is good array. So in this problem, we are given two integers n and k, and we are given an array a1, a2, an of length n, which consists of zeros and ones. And this is good if for all integers I from 1 to n, both of the following conditions are satisfied. That is, at least I by k, seal of I by k of the first I elements of A are equal to 1, and also at least seal of I by k of the last I elements of A are 1. Okay, and seal, everybody of you know the definition of seal, that is seal of I by k, and we want to find the minimum possible number of ones that will be there in a good array. So let us see how we can do this. Okay, so let us say we are given some n and we are given some k. Okay, so now we want to form an array of length n. Okay, and we can only use zeros and ones, and we are also given some k. Okay, we are also given some k. So what we want is that for every I, let's say you take a prefix of length I, and you also take a
Sir,
prefix of suffix. Yeah,
sir, are you writing? Because
yes, yes.
nothing is your only code forces screen is visible. Notepad is not visible, I guess.
Okay. Can you see my iPad now? Like I have written something over there.
No, sir.
No,
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 sir.
no.
maybe
Okay,
you shared the window
let
instead
me,
of sharing full screen.
yeah, let me just pause and resume. Can you see my screen now? Like I have opened the first problem.
Yes.
Yeah, problem is
Yeah,
visible, but
it's visible.
Okay. Okay. So now, can you now see the like my iPad screen?
Yeah,
No,
only
sir.
the Chrome window is visible.
no, no.
Only Chrome window is visible, not my iPad, right?
Yeah.
Okay. Can you see it now?
No, sir. No, sir.
I guess instead of sharing whole screen, you just shared a window. Like we can't even see it, the taskbar.
Okay. Okay.
Unshare.
Okay.
Yes.
Is it visible now?
Yes.
Yes, sir.
Yeah. I hope the iPad is also visible, right?
Yes, sir.
Okay. Okay. So I was discussing the first problem A. Okay. So in this problem, basically n and k are given, and you have to form an array of n integer an array of length n, which consists of only zeros and ones, right? And there is a condition that for every, let's say you are fixing some I, so for the prefix of length I and suffix of length I, both of these should consist of at least seal of n I by k once. Okay, so both of these should consist of at least seal of I by k once. Okay, and we have to like construct such an array A such that it consists minimum number of ones. Okay, so you have to use minimum number of ones. So how we can do this? So first of all, you can see one thing, that if your I is equal to 1, okay, which means 1 by k, if you take the seal of 1 by k, so this will always comes out to be 1. So it means that prefix of length 1 should consist of 1. So there is only one way in which a prefix of length 1 can consist of 1, that is by putting 1 at the very first element. Similarly, your suffix should also consist of 1, which will be of length 1. So you will always put a 1 at the end of the array as well. Okay, now you see, uh, if you just index it in one base like this, and let's say k is equal to 3 in this case, so up to this point, that is up to this point, you will be having no problem. You can always put 0 like this. Okay, because up to this point the value of I by k will come out to be 1 always, right? The seal of I by k. But as soon as you reach this point, you need at least two ones. So what you can do, you can put 1 over here, right? Again, if you just keep on increasing your I, so you can put zeros like this. But as soon as you reach here, you need at least three ones, but up to this point there are only two ones, so you can put one over here, right? Similarly, you can put zeros like this, and at the end you see here there is already one. If there was not a one, you could write one over here. Okay, so what happens here is that you can construct your array like this. If you observe, you can construct your array like this. That is, first of all, you will write one at the very first place, then jump k places ahead of this position. Okay, and then write one over here again. Again, jump by k positions ahead, write one over there. Keep on doing this until and unless your index goes out of bound, right? And at the remaining places, you will write zeros, right? And also by the first observation, you see that when you choose I is equal to 1, then in that case this should be 1 as well as this should be 1. So the last element should be ensured to be 1. So by keeping track of these two conditions, you can count how many minimum ones you need to construct your array. Okay.
Sir,
Hmm.
I have a doubt.
Yeah.
By placing one at these indices, we just confirm that from the beginning,
Hmm.
if we start, we should keep one at I plus k position. What
Hmm.
about in the reverse condition? Condition should also satisfy in the reverse manner also.
Yeah, so you are talking about you are clear about the prefix, right? That if you
Yeah,
choose
yeah.
any prefix of length I, it will consist of exactly I by k, seal of I by k once,
Mhm.
right? But you are not sure whether it will work for suffix or not, right?
Yeah, yeah.
Okay, so let us see how it will work. So whenever you fill your array like this, that is, you place one, then you place zeros, then again after k positions after this zeros, let's say you are forming your array like this. Okay, so the beauty of this array is that, let's say in this case k is equal to 4, right? Because you see after every 4 positions there is one, right? So the beauty of this array is that if you take any subarray of length 4, it will consist of exactly 1 1. For example, if you take this subarray, you see this consists of exactly 1 1, right? Any subarray you choose, it will consist of exactly 1 1. So
Yeah,
this, yeah,
is it necessary to take the subarray of length 4?
no, 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 no,
We
I'm
can
just,
also take subarray of length 2 or 3.
no, no, like suppose n is given something, right? And let's say k is given as 4, right? So in that case, we would be forming our array like this. That is, first we place 1, then again 4 positions ahead 1, then again 4 positions ahead 1 like this, right?
Yeah, right.
So what I'm telling is that if you observe in this array, if you choose any subarray of length exactly k is equal to 4, any subarray of length 4, it will consist at least 1
Yeah, I agree that.
Yeah, you agree? Now, uh, so for that, this is the reason why whenever you choose a prefix like this, okay, so let's say your I is somewhere here, right? Your I is somewhere here. So you see there are two blocks, there are exactly two blocks, so they will consist of one ones. Now this I is also crossing this block, so it will also consist this one as well. So this is the reason why whenever you choose a prefix of length I, it consists of exactly I by k, seal of I by k ones, right? Now the question was for the suffix, what happens for the suffix, right? So for the
Yeah,
suffix, what you can see here is that uh, if you try to form your blocks of size k from the reverse, let's say, okay, so let's say you are choosing a suffix of length I like this, right? You are choosing a suffix of length of I like this. Then as I told you, it will consist of I by k, seal of I by k uh, minus one blocks, like which completely lie to the right of it. So there will be at least one in this, at least one in this, right? Now you are not sure whether this block will contain, like, the up to this position, whether there will be one in this, in this or not. But since you are placing one at the here also, right? So if you add one to it, you get at least seal of I by k number of ones.
I should not get it. The this part.
Okay. So what I'm telling is that, let's say you are choosing a suffix of length I like this. Okay. Now try to form blocks of length k from the reverse like this, right? Let's say like you form blocks like this, right? Each of them of length k from the reverse. Now you know that this will consist of at least one. This will also consist of at least one. This will also consist of
Yeah,
one, right? But if you see this suffix like crosses four number of blocks, like overlaps four number of blocks, so this should consist of at least four ones, but here you are having only three ones. But if you just put one at the end, then what will happen is that this also consists of one over here, like
yeah.
before,
So the
like, yeah, like
we'll get
before
four
putting,
in the fourth block. Yeah,
yeah. So that's why it will now consist of four number of ones
yeah.
if
Okay,
you put
I
one at
got
the
it.
end. Yeah.
So we'll make it. We'll possibly make the last element to be one
Yeah.
in every case. Okay.
Yes, that has to be done for every case, because as you can see, when I is equal to 1, then in that case the first element has to be 1, and
Yeah, yeah.
similarly the last element has to be 1 as well.
If I was 5,
What?
if I was 5,
I was 5. I didn't got your point. Are you giving me any test case?
right,
Yeah, tell me. I is equal to 5.
and K is 4,
K is 4. Okay. So in this case, you have to form like this: 1, 2, 3, 4, and 5. So you can put one over here, and then after four places, you put one over here, right? Then you also need to place one at the end, but there is already a one, so you don't need to do anything. So in this case, you see there is two number of ones needed.
okay.
Sir,
Yeah.
sir, I did not understand that why we are putting one in the last. Can you explain it again?
Okay. See, you know that for I is equal to one part, that is clear, I hope, because
Yes, sir.
you need definitely one at the start and definitely one at the end, right?
Yes, sir.
Now, for the prefix part also, I hope that was clear, that how if you put
Yes, sir.
sequences like this, you get exactly
Yes,
I
sir.
by k seal ones, right? Now,
Yes, sir.
if you consider a suffix of length I like this, right? Now try to break it into blocks like this from the very end. Okay, let's say like this. Okay, now you see how many blocks will this suffix of length I like overlaps, or like how many ones is needed in this suffix. It needs exactly these many blocks, sorry, these many ones,
Yes, sir.
right? But how many blocks is like it is necessarily covering, like completely overlapping? That will be like seal of like floor of I by k. That will be like definitely these are like completely covered by this suffix, right? So
Yes, sir.
in each suffix, or like in each block, there is exactly at least one, right? Here is also one, here is
Yes.
also one. So if you consider this suffix, there is at least this much sum, right? But in
Yes.
addition, if you also put a one at the end, so it will become this one. So you know this identity that this always holds. Okay,
Okay, sir.
so
Yes.
now this contains at least these many ones. So this is definitely greater than or equal to the seal of I by k.
Okay, sir.
Okay,
Thank
so I hope this is clear to everyone, or if anybody is having doubts till now, they can ask, or we can proceed to the next problem then.
So we have to construct the array or there is a formula.
You can construct the array as well, or you can also use some formula like n is very, when it was very small, like up to 100 only. So sorry, I just constructed it. But you can also use a formula, simply n by k, take the floor of it, and check for the last condition that it should not occur that the last element is counted twice. Okay. So what I did, I just make a start pointer. It is starting from 1, and we are updating it by placing it k steps ahead each time, and we increase our answer by 1 every time, and we keep a map. So map is used for whether a particular index has been set to 1 or not. So at the end, I am checking if the last index, that is n, has not been already set to 1, then I need to set it to 1. So I again increase my answer by 1, and at the end I just print my answer. Okay, so this is clear, right? You can also do it using some calculation or formula work, but since constraints were quite small, I did not care to do it, but you can definitely do it using formula as well. Okay, so now let us move to the next problem, which is lamps. So in this problem, it's given that you have n lamps, and they are numbered from 1 to n, and each lamp I has two integer parameters, which are ai and bi. Okay, and at each moment, each lamp is one of the three states. So there are three states associated with a lamp, which are turned on, turned off, and broken. Now initially all lamps are turned off, and in one operation you can select one lamp that is turned off and turn it on. You can't turn on broken lamps, right? You receive bi points for turning on lamp I, and thereafter happens this operation, that is, let's denote the number of lamps turned on as x. Broken lamps should not be counted. Now all lamps I such that ai is lesser than or equal to x simultaneously break, whether they were turned on or off. Now what you have to do, you can perform this operation arbitrary number of times, and you have to find the maximum number of points you can get, right? So let us see how we can do this. Okay, okay, so in this problem you are basically given n lamps, right? So there are n lamps, and there are some parameters associated with each lamp. These are called ai and bi. So let's say you're given a1 b1, a2 b2, a3 b3, like this. Okay, so there are n lamps and their associated parameters like this, right? Now initially all the lamps are turned off, right? And then what you can do, you can turn on these lamps. So let's say you decides to turn on this third lamp. So if you turn on this third lamp, you will get v3 unit of like score. Okay, Okay, so you just add this B3 unit to your score. And after that, you just see how many bulbs are turned till this point. Let's say there are X bulbs which are turned on, right? After that, all the bulbs which are having their AI value lesser than or equal to this count, they will just get broken. It does not matter whether they are turned on or turned off, they will just get broken. Okay, so in this way, if you just apply the operations optimally, you have to find what is the maximum total score you can get, right? So let us see how we can do this, right? So let us consider that there is a bulb which is having a AI value with this AI. Okay, now let's say there are X bulbs. There are X bulbs which have this AI value equal to this AI. Okay, now the observation here is that if let's say this AI is equal to 5, okay, so it means there are X bulbs whose AI value is equal to 5. Now the observation here is that you can never get or like you can never turn on more than 5 bulbs whose AI value is equal to 5. Okay, you can never turn on greater than 5 bulbs whose AI value is equal to 5. Now the reason for this is that let's say you turned on a ball with AI value equal to 5, right? You again turned a ball with AI value equal to 5, again 5, 5, 5 like this. Now as soon as you turned on 5 bulbs, right? After this broken operation will take place, due to which all the bulbs whose AI value is lesser than or equal to 5 will broke down, right? So all these bulbs will just break down because all of them have a AI value equal to 5, and all the bulbs whose AI value is equal to 5 and even they were turned off, they will just also got broken, because as soon as you turn on 5 bulbs, all the bulbs with AI value equal to 5 will broke down. That's why I'm saying you can never turn on more than 5 bulbs with AI value equal to 5. So is this part clear to everyone?
Yes.
Yes, sir.
So what you can do, you can now like predict the answer. What can be the answer? The answer could be like you can just iterate over the value of AI. So it's given that AI ranges from 1 to n. So you can fix some AI value. Let's say AI value is equal to y. Then you can count how many bulbs are there whose AI value is equal to I, and and just store their BI values, right? So you store all the BI values associated with this AI, right? After that, you know that you can only choose AI of them. So greedily, you will try to take the bulbs with the maximum BI values. So you can just sort this list in the decreasing order of their BI values and take Y of them. Okay, and take Y of them and just add it to your score. The same thing you can do for each of the AI values. You just fix some AI value, you find what are all the bulbs with this AI value and store their BI values, reverse sort them in reverse order, decreasing order, and choose AI of them or Y of them and add it to your score, right?
But for next AI value,
Hmm.
the value of previous AI also we Y also we counted.
No, what you can do, you can go in increasing order of AI. So let's say you can fix AI is equal to 1, right? So let's say there are 10 bulbs whose AI value is equal to 1, right? So you store their BI values, you take the highest one of them because AI is 1. So you take the highest one, right? So once you take this first bulb, obviously after that all the bulbs with AI equal to 1 will just break down, right? After that you move to AI is equal to 2, right? Let's say for AI is equal to 2, there are 20 bulbs, right? 20 bulbs. So although there are 20 bulbs, you choose only 2 of them, because as soon as you will start turning it on, so let's say you turned on this ball, so there is exactly one bulb which has been turned on. So all the bulbs with AI value lesser than equal to 1 will break. But already all the bulbs with AI value 1 has broken. So that means no bulb will break, right? So you will add this score. After that, you again, let's say turn on this bulb. right? So you add its score. After that, count becomes 2. So as soon as it becomes 2, like all these bulbs will just broke down, right? So that's why we are taking the highest BI values, highest two BI values for AI equal to 2, right? Similarly, when you move for AI equal to 3, as soon as you start turning on these bulbs, like for AI 1, 2, like already all the previous bulb has been turned off, or like sorry, broken down. So as soon as you start turning them on, they, like nothing, like previously all the bulbs has already broken, so no extra bulbs will break. But as soon as you reach the third bulb, you turn this third bulb on. After this, all the uh, bulbs with value AI value equal to 3 will broke simultaneously. Okay, and when you are like turning on bulbs with AI value 3, obviously bulbs with AI value greater than 3 will not be affected, because you can't uh, you can't turn on more than 3 bulbs.
Excuse me, sir.
Yeah, hello.
So what if the number of bulbs are less than the AI value?
Yeah, if the number of bulbs is less than AI value, so in that case you will just break only that many bulbs as many there are. So let's say you are considering AI to be equal to 4, right? So you can break, or you can turn on maximum of 4 bulbs. But if there are only 3 bulbs available, so definitely you will just turn on all of the 3 bulbs only. Okay.
In that case, we won't go to the
Hmm.
AI plus one maximum value.
Yeah, you won't go like up to all these AI, because there are only 3 bulbs. So definitely you can't just like go up to 4 bulbs, because there are only 3 bulbs. So you will break them one, you will turn them on one by one. Although even after turning all of them, none of them will break, right? Because your AI value is 4, so you turn them. So each of them is having a AI value of 4, but there are only 3 of them. Sorry, but there are only 3 of them. So since 4 is not lesser than or equal to 3, so like none of them would break.
So I meant like if AI equals to 4 and bulbs are 3,
Hmm.
in that case we won't go to AI equals to 5 and we'll choose the highest BI value from AI equals to 5 and we'll turn that on.
Yeah, like once the case of 4 is over, like we can go to 5, and then up, then to 6, 7, like this.
Where I meant to ask, like to complete the number of bulbs turned on
Hmm.
equals to the
Hmm.
value of AI. So if in case it has less number of bulbs, won't we
Hmm.
go to like the next AI value? Like if AI equals to 4, then we'll go to AI equals to 5 and we'll choose one bulb from it, which is having the maximum BI.
Hmm.
In that case, we'll have a total of four bulbs turned on, and then we can break all of them.
Yeah.
Because one of the test case given in the
Hmm.
problem is using the
Hmm.
same technique. Like their number of bulbs for AI is less than the AI. So for that, they were taking the value from the next AI, like in AI value greater than the previous one.
Okay. So you are saying that if AI is lesser than your, okay, count of AI, sorry. If count of bulbs with AI is lesser than AI, right?
Yes, sir.
Okay. Hmm. Okay. If count of
Well,
AI is
in problem test
hmm.
case 3 is using the same technique which I'm saying.
Okay, let me see what is the third test case. Okay, let me write it. Okay, so we have 1, 2, then we have 3, 4, then again 1, 4, then 3, 4, then 3, 5, and 2, 3. Okay, so corresponding to 1, we have 2 of them, that is 2 and 4. Corresponding to 2, we have just a single one, and corresponding to 3 we have 4, 4 and 5. Okay. Okay, so in this case, let me share it. Okay, so in this case, we can first of all break the bulb corresponding to AI equal to 1. So let's say we break this one, right? Okay, after that, we can, if we try to break this one, that is for AI equal to 2. So in this case, we will only be able to like turn on this one, but this won't break as well. Okay. After that, if we move to the next one, then we can just break. Uh,
We can pick 5, the value which has BI value equal to 5,
Yeah.
and then the number of turned on bulbs will be 2. So we can break both 3 and 5.
No, after that only like this will be broken, because as soon as you choose this one, and this was already turned on, this has not broken, but as soon as you choose this one, like this will get broken automatically, because there are 2 bulbs on and this was on but was not broken. So as soon as you choose this 5 corresponding to AI 3, then this will get broken, because the count now becomes 2, and this AI is lesser than or equal to 2, so this will get broken. So after that you can choose these 3 bulbs as well. So that's why I was telling that if you can just try on choosing the bulbs or like turning the bulbs on in the increasing order of the AI values. So in that case, you will always be able to pick like the, if 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 there are a count of AI bulbs with this AI, you can always pick at least this much, or like whatever is the size of this AI.
Yes, now I got it. Like it's the same thing which you were telling earlier.
Yeah. That was the same thing.
Okay, so
Okay. So let's move to the code of it. So now here we are just taking the input as usual in our array A and B. After that, what I am doing is that for a particular AI, I am storing what are all the BI associated with it in the form of a vector. So just iterate through all the AI BI, and in V of AI, push back BI, right? After that, I just iterate for each of the bulbs with a fixed AI value. So that's why for I is equal to 1 to n. After that, I just sort it in reverse order. So first I sort it, then I reversed it. So corresponding to some fixed AI value, I have my all the BI values associated with it in decreasing order. Then I find what is the size of it, right? What is, how many bulbs are there? So definitely we can take only minimum of how many bulbs are there and what is the AI value. So I take the minimum of that. Those many bulbs can only be like added to our score. So I iterate for the first largest that many of the bulbs and add its score value, that is V of ij. And at the end, I just print my answer. Okay. So I hope this was clear to everyone, right?
yes.
Okay. So now let us move to the next problem, which was problem C. So in this problem, you are given a sequence A1, A2, An of length n, where each element is either 0 or 1, and a sequence B which is initially empty. Okay. And your target is to make your B equal to A by doing some operation. And you are given the operation, like how you are performing this operation. So on the ith operation, you choose an integer P between 0 and I minus 1. Then you insert 0 in the sequence B on the position P plus 1, and then you invert the first p elements of the b. More formally, it's given that let's denote the sequence b before the ith operation as this. So on the ith operation, you choose an integer p and replace b with this. So as you can see, you have inverted the first p elements. After that, you have inserted a 0 and all the elements remain as it is, right? So you can clearly see, since we are adding a 0, the size of array b will increase by 1 after each operation. Okay, so we have to determine if there exists a sequence of operations that make b equal to a, and if such sequence of operation exists, we also need to find it. Okay, so let's see what can be done for this. Okay, so it's given that you are given an array a, which is basically a binary array. Each element is either 0 or 1. So consider binary array like this. Now you are also given b, array b, which is initially empty. Okay, now what you can do, you can just, like, let's say if your array b form till now looks like this. Okay, so you can choose some prefix of it. Okay, you can choose some prefix of it, reverse it, and append a 0 after it. So let's say you choose this prefix, just reverse it and append a 0 after it. Okay, so this get copied as it is, this got reversed, and you added a 0 after it. Okay, so this is how an operation looks like. So
It
you have,
should be 110, right?
no, like I have choose p to be equal to, sorry, 1 minute here. Okay, sorry. So here we have chosen prefix of length 3.
Okay.
So that's why after this third position, I have appended a 0 and then inverted the first, like, prefix of that length, that is length 3.
So it was 011, so it should be 110.
No, here inversion doesn't mean reversing. Inversion means 0 should be changed to 1, 1 should be
Okay.
changed to 0.
Okay.
Okay, so if you see here that we have inserted 0 over here and then inverted this. Okay, if you can also choose an empty prefix here also. So choosing an empty prefix will, like, uh, just add a 0 at the very beginning, and everything else will remain as it is, like this. Okay, so this is like copied as it is. Okay, and a 0 has been added at the very beginning, and since previous to is there is an empty prefix, so like inverting it doesn't makes any issue. So we have just appended a 0 at the very beginning. Okay, so now we have to, like, say whether we can convert this b array to a or not. Okay, so if you just reverse the problem, right, that is, if you just ask that if I can start with array a and can I convert to an empty array b. Okay, so so initial operation is what? Initial operation is that you choose some position p, reverse or like invert the prefix of length p and add a 0 after it, right? So you choose a prefix like this. Let's say the prefix is of length p, add a 0 after it, and everything else remains same. Okay, so what could be the reverse operation of this? Like just the operation which can be said to be opposite of it. So the opposite operation can be said like, you are given an array like this. Okay, you choose a 0 from there, remove it, and then invert the prefix of it. Okay, so let me give you an example. So if you consider this example only, that was 0 1 1 0 1 0. So let's say you choose this prefix. Okay, so you inverted this, and after that you appended a 0, right? So as a result you get this. So we can say, like, can we convert this to this? Yes, we can convert. How? We can choose this 0, like we can remove this 0 and invert this. Okay, so if you remove this, invert this, you get again from b to a.
Yes.
Okay, so actually the entire problem can be modified as like you can just redefine the operation. The operation can be redefined as like you are given an array of zeros and ones. You can choose some zero. You can remove this zero and invert the prefix previous to it. Okay, so start with your array A. Okay, try applying this modified operation on the array A and try to make this empty. Okay, so instead of trying to go from B to A, where B was empty array, try to go from A to B. Okay, you start from A, apply this modified operation and check if you can just make your array A empty. Is this point clear?
So we will choose the leftmost zero.
Yes. So I'm coming to this. So basically what you have to do, you start with your array A, okay, and try to choose a zero, remove it and invert the prefix of it. So when it can be possible that you are not able to apply any operation on A, that would be possible only if there are no zeros left. The array A consists of only ones. In that case only you would not be able to apply the operation. Otherwise, you can always find a zero, remove it and just invert the prefix. Okay, so which zero should I choose? That is the point to thought upon. So let's say your array consists zero at several places, right? Let's say it consists zero here, zero here, zero here, zero here. Okay, so you can see here that it is best to choose this first zero. Okay, it is best to choose this first zero, because once you choose this first zero, remove it, like these zeros are always preserved, you can always choose them later. Okay, so what we will do, we will choose the leftmost zeros first. So let's say this is the first zero that is occurring in your array A. Okay, so if this is the first zero, let's say the index of this is I, right? So it means that you will let's say the index is I, it means that there are I elements to the left of it. So let us consider zero based indexing. So if the index is I in zero base, it means there are I elements to the left. So you will just put this I into your like operations array. Let's say you are maintaining a list of operation, like at what indexes you are applying the operations, right? So you just put this into your operations array, and after this you will just invert this. So since this was the first zero, it means that all the elements previous to it must be one, right? So since I am choosing the first zero, so as soon as I choose the first zero, remove it, and if you invert it, you will get 0 0 0 0 0 only, right? And like this part will remain as it is. Okay, so after this you can just simply keep on choosing these zeros. Okay, and each time you choose a zero, since prefix is empty, you don't need to do anything, right? So you can simply put zero into your like into your operations array. Okay,
Yes.
so after this all the zeros will be like these will be removed. You can again start searching from this. You can start searching like which is the first zero. Now you will get this zero, right? You can just add what will be the position of this zero in this modified array, and after that when you invert this, you will add only zero for these.
So, sir, when we don't have a zero in the very last index, then we can surely say that we cannot make it an empty array.
Yes, that is the check you can do. That is the check we definitely need to do that. If there is not any zeros found, then in that case the answer is no.
What is another check?
Like that is the only check you need to do. Like see, uh, you start searching from the very first element of the array. Try to see where is the first zero occurring, right? Let's say the first zero occurs over here, right? So you can definitely apply an operation on this, right? So after applying an operation in this, like all the elements previous to will get converted to zero. So you can safely like cancel out these zeros one by one, right? So once this is done, your new array will be like this one, this suffix. So if you have processed till this point, you now need to proceed up to this one. So again, try to find out where is the first one occurring. If you can't find any, sorry, where is the first zero occurring? If you can't find any zero, that is all of them are, let's say 1 1 1 1 1. It means you can't convert this to empty array. Okay.
Yes.
So I am like telling you the steps how you will do this. So start from the first index, find the first zero occurring. Let's say the first zero occurs over here, right? And let's say this is the j pointer. Sorry, yeah, let's say this is the j pointer, or let's call this as I pointer. Let's call this is the I pointer. So I pointer means that we have this suffix remaining as our array. We have this suffix remaining as our array. So once you have this suffix as your array, you start to the right, find the first occurrence of zero. Let's say first zero is occurring at index j. Okay, so it means that you will insert j minus I into your operations array. Why? Because although indexing is I to j, right? But actually this array, if you index is in zero, like 0, 1, 2, 3, so you will find that there are like j minus I ones to the left. So in the actual operation, you will be doing the operation for p equal to this much. Okay, so you will put
Could you
this.
please repeat this point, sir?
Yeah, so let's say when I was equal to 0 and let's say j is equal to 5, right? So it means j is equal to, let's say, 6. Okay, so it means what? That you will actually perform your operation for p is equal to 6. Why? Because previous to 0 there are 6 ones, so you will be inverting prefix of length 6, right? So that's why you will insert 6 into your operations array. Okay, because if you see in the problem,
Sir, how is I related to P in this formula?
okay, so like if you see, you can choose some p, you insert 0 in the sequence b on the position p plus 1 after the first p elements, then you invert the first p elements of the p. So it means that if you are inverting the first p elements, right, then you need to put p into your like operations array, because here you have to print the p values, right? So if you see here, uh, you find the first zero occurring in your array. Let's say this is occurring in position j, right? So how many, like how many ones are to the left of this j? So that will be j minus I.
How I is related to P and J in this formula?
Okay, so see, what I am saying is that for now, let us assume that I is 0. Okay, let's say I is equal to 0. You found the j, right? After that you will be deleting this 0, right? You delete this 0, and then you will be inverting this subarray, like this prefix, right? So as a result, you will get all of them to be equal to 0, right? So you will get like 0, 0, 0, 0, 0, 0. After this, these ones will be copied here like this. Okay, after this, you will be just removing these zeros one by one, right? Because once you remove this 0, the prefix is empty, so you don't need to do anything. Again, you would be removing these zeros out one by one. Okay, and for each of them you will be putting 0 into your like operations array or answer array. Okay, so we are just doing this task in one go. Okay, so once you do this task in one go, like remove all these elements, your remaining array becomes a suffix from this to this. So this I indicates that now we have our remaining array a suffix which is starting at I.
So I will become J plus 1.
Yeah, I will become j plus 1 after this. So basically your I will be starting from I equal to 0. You try to find the first 0 occurring, right? Corresponding to this 0, you see how many ones are from I to j. Let's call this p. P will be actually in fact j minus I. Put this j minus I that corresponds to applying operation on this. After that, you also put 0. You also like, since they will all be converted to 0 after removing this 0, so after this you will be putting these many zeros into your array because you will be removing them one by one. After that, your I will become equal to j plus 1, because now you need to do the same thing on this suffix array. because this part has been done. This part has been eliminated. You have also stored the operation for removing this array, this prefix. Did you get it now?
Yes, sir.
Okay. So let me show my code for this. So basically I am taking the array A as an input. After that, I am declaring a vector V. So V will be storing the operations. Okay. So I am starting a J pointer. J will be initially starting from I. So while J is lesser than N and A of J is equal to 1. So while I am getting 1, I am incrementing my J by 1. So as soon as my AJ becomes equal to 0, this loop will definitely break, right? So if J becomes equal to N, it means that I didn't got any 0 at all and I traversed the entire array. So in that case, I print simply no and return. Otherwise, I store J minus I, that is the P value for applying the operation at this 0. After that, I start from K is equal to I to J, okay, and put 0, because as you can see here that if your I was here, J was here, so you put J minus I corresponding to removing this 0, right? After that, you also need to remove these zeros one by one. So that's why I'm starting a loop from K is equal to I and removing them one by one, and I move up till J minus 1, or while K is lesser than J. Okay.
Sir, how you
So
got the intuition to solve this problem in a reverse manner?
So, like actually, I first tried to simulate the same thing in the forward manner, right? But after that, I observed that whenever I try to do anything, like applying the operation after it, it's actually changing the prefix of it. Okay. If you'd also try to simulate the same thing in the forward direction, that is in the way that it has been given in the problem, if you try to do it, you will find that whenever you insert 0 at any point, you are basically changing the prefix, like the prefix is getting inverted, right? So it is very difficult to maintain the prefix. Did you get my point?
Yes, sir.
But if you try to think in the reverse manner, that instead of adding 0 and then reversing, try to think of the reverse way, that is we are deleting a 0 and inverting a prefix, and try to think in the backward direction, that can I convert A to an empty array? So that makes much more sense. Like there
So,
may
sir,
be possibility that there is might be a way to solve it in the forward direction as well, but like thinking in the backward direction, I think it was much easier for me.
so first you went in the forward manner only, like, and then you
Yeah.
found the correct approach.
Yeah. So basically, if you will also try now, you will see that whenever you try to put a 0 at some place, thinking that it will try to make B similar to A. After that, if you try to apply the like putting 0 at some other position, like your prefix will just get disturbed. So it was very irritating to like maintain like that it is matching to A. That's why I try to thought in the reverse direction, and this is the like a general approach you can apply in any kind of problems where you are given some operation kind of thing, that is you are doing this, can you convert A to B, B to A, like this you can always try to solve the same problem in the reverse way. Like sometimes it is impossible to solve in the reverse way, but sometimes it makes sense and it is even easier to think in the reverse direction. Okay, so that was the intuition.
Yes, sir. Because when I tried to solve it in forward manner,
Mm.
the only solution I could come up was brute force, and it was taking time complexity of n factorial, which will definitely give you TLE in
Mm-hmm.
the given constraint.
Yeah. Yeah, actually, if you try to simulate in the I didn't even come with any approach like how I can maintain it. But if you're saying like it might be possible that you would be encountering such a huge time complexity, but that
So
is
like
in fact not
I
feasible.
also didn't get any approach. I was like trying all the possible situations, like the explanation which they have given in the last test case, like they were trying all the possible situation when p equals to 0, there will be 6 case, then p equals to 1, there will be 3 case, and p equals to 0 will be second case. Like, so I was trying all the possible ways in n factorial ways.
Okay, but that I think is too much of brute force. Like that
Yes, sir.
definitely. Yeah. Okay. So if you now come to here that if j is equal to n, so I just simply output no. After that I put the p for removing this 0, that is j minus I. After that I iterate for k is equal to I, k lesser than j, put 0 for all of them. And after that simply set I equal to j, so that when I got incremented in the next I to be checked becomes j plus 1. Okay. So if you don't hit no anywhere above, so you will simply print yes. Then you also need to reverse your operations, because you are trying to convert B to A, right? The original goal is to convert B to A, but what you are doing is you are converting A to B. So all the order of operation has to be reversed, right? Because you have to finally output the order in which you will be converting A to B, not B to A. So that's why we reverse this answer array or vector B, and at the end we just print this B. Okay. So I hope this was clear to everyone.
But in this solution, it is the time complexity is big of n square.
No, this is not big of n square. This is big of n log n. Sorry, this
Big
is
of,
O of n. Because you see, when we are traversing for I is equal to 0 to n, like I am just chunking all the ones together. Like while I am getting 1, I keep on incrementing my AJ until and unless I get a 0, right? So once I get a 0, after that, see, I am setting I equal to j. So I am never like traversing the same index twice. I am iterating over each index exactly once.
yeah, got it.
Okay, so although it looks like O of n square, it's actually O of n. Because you see, it is because of this region, I equal to j. Like once you traversed from j equal I to j, your next I becomes j plus 1. Okay.
And D problem.
I didn't solve D problems, so I won't be able to like discuss it